we are going to present on this topic of lightweight aggregate. Okay, so basically we know that what concrete is. It is a mixture of what ongoing concrete trend, like what we basically use is cement, then aggregate and water constituent, and along with that we have sand particle. In general, what we usually use. But in the course of time, when things change, then budding minds, getting scientists used and try to explore the other domains of aggregate so that they can either make it more economical, or they can look the other perspective of concrete, how it can be modified so that it can be used in development and better structures. Continuing that trend, a topic came out of that regarding to lightweight aggregate. So this is basically it's a versatile building material, as you can see, known for its reduced density. As its name signifies that it has a reduced density, and it has enhanced thermal and acoustic property, and which is made up of incorporating lightweight aggregate in the mix, resulting in a durable and sustainable and high performance concrete. So overall, the intention of this entire topic and research is that we have to somehow make the aggregate and material high performance and durable, along with maintaining its sustainability in the long run. So continuing to that, we can see the more highlighted point that this type of concrete that utilizes lightweight aggregate to reduce its overall density, resulting in lighter weight compared to other traditional concrete that what we generally use, and which is used in most of the cases. Apart from this aggregate includes expandable clay, slate, which contribute to the specific property of the concrete. So since we had to reduce its density and its weight, with respect to what we have, we had to add some additional material, which is clay, slate, and slat, that is changed from what it used in daily life. Then we will move to the type of aggregate. So here we have natural lightweight aggregate. Some examples are pumice, pertile, and volcanic cinder. We don't have very much variation in that, since inventions and research are going on. Apart from that, we have some traditional lightweight aggregate, which have been created by the industrial bike product that I recently mentioned, clay, slate, and slate. Apart from that, we have one more type, which is foamed slate aggregate, which is produced by molten slag and a foaming agent to create lightweight granules. Even now, what we use in concrete, we have a lot of material which come from slag. So similarly, they try to modify the on present slag what we have, and try to bring a new form out of that. Now we will see the advantages. So the basic advantages are that it has heat insulation on roof, it has insulation on water pipes, construction in partition division wall, general insulative and sound wall, decks of long span bridges, fire and corrosion protection, covering for architectural purposes, filling for floor and roof slabs. Since we know that it has a lightweight, then it reduces the overall weight of the structure, leading to the cost saving in transportation and construction. So the basic, we know that in the construction of building, it is a long process, right? From purchasing a material, even before that, manufacturing of material and taking into the construction site, making the entire mixture, then providing it for casting, and then the final structure comes. So in that entire process, we have a longer process. So they try to cut on. It is very important to make things economical, so that it can be more profitable and durable. We have some advantages like these are fire and corrosion protection in comparison to what we traditionally use. It has also more heat insulations because of its property. Since its light is weight, it provides more insulation toward the heat. Uh, So it's now what are the applications where we generally use this type of aggregate? The first is bridge constructions. Usually lightweight aggregate is commonly used in bridge construction due to its reduced dead load and increased durability, which enhances its longevity, means it work for a longer time than longevity of the structure. Overall, these things are bring which usually we expect that at least a bridge or a long or any structure that is meant to serve for a longer period, that should be economical. So breeze is a major use of lightweight aggregate. Then we use it as a soundproofing, as it is excellent sound absorption properties that makes lightweight aggregate concrete ideal for soundproofing in building, theaters, and recording studios. Apart from that, we have geotechnical applications, which is used in geotechnical engineering for backfill. In fact, lightweight aggregate concrete minimizes settlement and provides stability in various construction projects. Then we have these are basic its properties of lightweight aggregate. It has low density, which I mentioned earlier several times. That lightweight aggregate has significantly lower density compared to traditional concrete, making it ideal for reduced dead load and structure. Apart from that, it has thermal insulation. It offers improved thermal insulation properties, making it suitable for construction in region and extreme temperatures. Then since it is fire resistance, then it providing its ability that enhanced fire resistance due to its composition and insulation properties. And ultimately, we have its structural performance. So which is our ultimate goal. So despite of its low density, it maintains excellent structural performance and durability, making it a versatile construction material. Okay, so our next teammate will continue further.
Thank you, Nilesh. Now I'm going to proceed in this topic. So the three components are that of lightweight aggregate that uh, first we the material is required for the preparation. We generally use different type of lightweight aggregates, that is clay, shell, and also like in particularly in shell, oil palm shells are majorly used, and also slag is used. Then mixing and batching. The lightweight aggregates are then mixed with traditional cement and water in specific proportions to form the concrete mix. And at last, curing and testing. And the concrete that is concrete mixture is simply poured in molds and then allowed to cure for a particular time, after which we test it in strength and durability. Rigorous testing is done for strength and durability. Next slide. Sulbit, next slide.
It is the next slide, Pradeep.
Okay, okay. Testing and quality control. Now, in the last slide, we have done that curing, and after which we test it for different parameters like durability aspect and other strength aspects. First is strength testing. This strength testing involves like compressive strength and tensile strength of lightweight aggregate concrete. That it is meeting the structural requirements or not. We test on that parameters. Second is durability assessment. Different tests are done for durability, it is resistance to freeze thaw cycles or chemical attacks or abrasion, like we have seen in normal traditional concrete. Same type of durability tests are done for this type of concrete also. uh, then quality control measures. Then how that a preparation that we have done in the manufacturing process, what are the what the quality control measures we have to implement so that we get a good concrete mix without any flaws. The non-destructive testing using methods like we have normally in concrete we have seen like UPS, ultrasonic pulse velocity, and rebound hammer testing. That is non-destructive testing. We also use here for non for using the after like for hardened concrete. We use this non-destructive testing. Next slide. Now, some examples and case studies that we that have done that are being done for using by using this lightweight aggregate concrete. The lightweight aggregate is very eco-friendly for residential construction because aggregate that we use are materials from like oil palm shells. These are pure organic materials, and also in bridge and infrastructure applications, like Nilesh have already discussed that it due to less dead load of and due to less density, and it provides less dead load to the structure. we use in large structures to decrease their load so that they they long laster and their durability will improve in future and their durability will improve. Then high rise building construction also same aspect because it reduces the overall weight of the building. That's why it is highly suitable for high rise building construction in some part. Next slide. Now, as I already discussing that in shells, we use oil palm shells as an aggregate in this type of concrete. Why we use this? Because it is sustainable solution. In particularly, these oil palm shells are found in Malaysia region due to on palm trees and it is agriculture waste, so we can use it in lightweight concrete. Environmental benefits are also there because traditional construction material will reduce by using this will reduce, and that why we can lower the carbon footprint. Then cost efficiency, incorporating matlab OPS into concrete production presents an environmental and economic advantages because it utilizes readily available agricultural waste. Then lightweight advantage because OPS concrete exhibit a lower density compared to normal concrete. That's why it is advantageous for lightweight construction and reducing structural load and transportation costs. Room for improvement. Like while OPS concrete should promise some future research and development is needed to enhance its mechanical properties and competitiveness with the other lightweight aggregate concretes. Next slide. Now some aspects of OPS we will discuss. Waste product, like we have seen that it is a waste product of palm trees, the palm oil processing units, so that we can use it by sterilizing and threshing it. Physical characteristics, like it comes in various shape and sizes, but we only use some specific sizes because of structural structural requirement. High water absorption. The OPS have a high water absorption capacity of 21 to 33%, much greater than the conventional gravel aggregates. Mm. That's why it is high pore content. Porosity and density. These OPS exhibit high porosity, 37%, and lower densities compared to traditional aggregates. Because it is high mm, porosity and low density, we can use it and 60% lighter according to the data. It is 60% lighter than normal traditional aggregates. Durability, despite its lightweight nature, it is hard and resistant to deterioration and lower abrasion and wear values compared to conventional aggregates. And also research is needed. We have I will discuss. Next slide. Now mixed design challenges. Um, we cannot like simply follow mixed design of traditional concrete. We have to modify it for preparing the OPS concrete. Uh, so it requires trial mixes due to OPS aggregation. Main problem is OPS aggregation. That's why we require trial mixes with cement content ranging from 400 to 600 kg per meter cube compared to 240 to 500 kg per meter cube. Normally, we use 240 to 500 kg per meter cube structural for structural lightweight concrete, but here we have to increase the cement amount. Now, research insights. Previous studies indicate that inadequacy of conventional methods like um, ACI for OPS lightweight concrete, necessitating specific mix proportions tailored to OPS concrete and desired compressive strength of 20 to 35 MPa. These are some sample mix like conventional concrete is slump is 190, the non-treated OPS 65 and treated OPS 183. Like after treating the slump value is increasing. It is more like workable, mm, increasing the workability and density on 28 days. Like normal concrete conventional is 2409, and after treating the OPS, it is 1798. So density is also reducing. And this is now importance of density. Uh, LWC, like lightweight concrete, typically ranges in 1400 to 2000 kg per meter cube. That is uh, significantly lower than normal weight concrete, that is approximately 2400 kg per meter cube. OPS concrete density, like it is 19 to 25% lower than ordinary crushed stone concrete. Then compressive strength, like compressive strength is a crucial parameter. Already know that. So by ASTM recommendations, it should be compressive strength should be 17 MPa, like minimum for 28 days. But lightweight concrete made OPS by using OPS achieves compressive strength ranging 25 to 35, mm, which is in range of structural lightweight concrete 20 to 35 MPa. Enhancement and concentrations, improving OPS aggregate quality. We have to like improve the quality, the processing of the OPS should be done so that in mixing of mixing of and processing of concrete, we should attain good aspects in durability and other factors in which it is lagging now. Uh, Thank you. And now the graphs are showing that OPS is absorbing because of it is more porous, so that it absorbs more water, and compressive strength is comparative to normal uh, lightweight aggregate, clay lightweight aggregate. The OPS lightweight aggregate is normally uh, matchable, or it is more like it is greater than normal clay lightweight aggregate. Thank you. Now I will call upon Sudhir to proceed the activity.
Thank you, Pradeep. So now moving on to the conclusion of the use of oil palm shells as lightweight aggregate, specific gravity. The specific gravity of oil palm shells range from about 1.14 to 1.37. That shows OPS are approximately 60% lighter than the conventional coarse aggregates. The 24 watt water absorption capacity is much higher than conventional gravel aggregates. It can be used as lightweight aggregates for the production of structural lightweight concrete. The physical and mechanical characteristics of OPS are different from the other types of lightweight aggregates. For this reason, the mix design is different and trial mixes are necessary to achieve a good mix design. The 28-day compressive strength of OPS concrete is in the range of the typical compressive strength for structural lightweight concrete, with a density of around 20 to 25% lower than normal weight aggregate. The splitting tensile strength of OPS concrete is slightly lower than the lightweight concrete made with cold bonded fly ash and palletized blast furnace slag lightweight aggregate. The flexural tensile strength of OPS concrete is lower than the lightweight concrete was made using expanded clay and shale aggregates. The modulus of elasticity of oil palm shells aggregates is lower than the other types of lightweight aggregate concrete. For this reason, the higher load bearing purposes, larger cross sections should be considered to satisfy the deflection criteria. Uh, so now we'll move on to the lightweight concrete with the help using pumice as aggregate and fly ash as the replacement of cement. According to the research, water absorption, lightweight concrete absorbs more water, about 5 to 20% by weight, due to its cellular structure. Internal curing, this water absorption helps in maintaining internal curing in the concrete for a longer time period. Pumice, the natural choice. Pumice is a volcanic rock with a sponge-like structure, ideal for lightweight aggregate. Abundant and eco-friendly, pumice is a readily available and environmentally friendly resource. Limited utilization, despite its potential, pumice hasn't been fully utilized in lightweight concrete production. Structural strength, studies show pumice concrete can achieve compressive strengths up to 25 MPa, making it suitable for structural applications. Compressive strength, concrete design priorities, compressive strength which pumice concrete can deliver. Global production. Italy leads pumice production, followed by Greece, Chile, Spain, Turkey, and the US. Pumice is primarily used in lightweight construction materials. Conclusion of experiment related to pumica and fly ash. The results obtained with 25% lightweight aggregate replacement in normal aggregate were studied with fly ash replacement in cement by 0%, 15%, 20%, 25, and 30%. At 20% replacement of cement by fly ash, the maximum compressive strength is observed for 25% and 33.33% lightweight aggregate replacement in coarse aggregate. The split tensile strength at 28 days for 0% replacement of cement by fly ash and 33.3% lightweight aggregate replacement in normal coarse aggregate is observed as 2.1 MPa. Further, split tensile strength at 28 days for 20% replacement of cement by fly ash and 33.3% lightweight aggregate replacement in normal aggregate is observed as 2.6 MPa. The flexural strength at 28 days for 0% replacement by fly ash and 33.33% lightweight aggregate replacement in normal coarse aggregate is observed as 2.9 Newton per millimeter square. Um, Further, the flexural strength at 28 days for 20% replacement of cement by fly ash and 33.3% lightweight aggregate replacement in normal aggregate, it is observed as 3 Newton per millimeter square. The Young's modulus at 28 days for 0% replacement at cement by fly ash and 33.3% lightweight aggregate. So, moving on to the conclusion and future prospects. Increased usage. Lightweight aggregate has a growing demand in construction industry. Technological advancement. Innovations are being done in lightweight aggregate production. Environmental impact. Using lightweight aggregate is a sustainable solution for reducing carbon footprint. As lightweight aggregate concrete gains momentum, its increased usage in construction projects, coupled with continuous technological advancements in aggregate production and its environmentally sustainable products, sets the stage for a promising future in the construction industry.